Good morning. I want to thank the organizers of this event held in San Juan for the first time. My intention is to show the objectives of Lithium 1. The work made until today and what is pending for the future, this year and next year. Lithium 1 has a brine lithium deposit in Salar de Hombre Muerto in the eastern side of Salar de Hombre Muerto. In this slide, you can see the border of the Puna and the different salares in the Puna, both in Chile, Argentina, and the south part of Bolivia. I hope you can see here in light blue which are the salares of the Puna. Hombre Muerto in the right lower part, the Antofalla, Pocito, and Rincón salares, Cauchari salar also. The location of these properties is lithium 1, and this is lithium contained in brines of the salares. This figure shows the distribution of the properties belonging to lithium 1 and the FMC mine, that is the only lithium mine in Argentina. We're neighbors. Our properties are one beside the other one. We have 365 square kilometers of mining property on the east side of the salar. The works made until today can be divided in the purchase of the mining property. This was made in 2009 and 2010. Then the work of geological mapping of the mining property concentrated in the surface of the salar in order to try to determine the different salt crusts and the different clastic and evaporitic phases present in the zone. And the other work consists on the sampling, brine sampling, and geochemical analysis of the samples. These samples are not surface samples, but superficial samples from 1 meter up to 7 meters. The brine samples were analyzed in commercial certified labs. Another work that has been made is a geophysical work. We have made gravimetric data collection and vertical electrical probing. Also, we have drilled holes with rotary conventional equipment for water well production to characterize the type of brine deep in the south part of the salar. Regarding the purchase of the mining property, this task was carried out by Héctor Vitone, a well-known geologist, and was carried out successfully. We have negotiated with 13 different owners. We purchased 68 properties from third parties. Most of them were Ulexita properties. And obviously, we have our own surveys in the zone. Regarding geology, this geological map is a regional map. In light blue, we have the saline crust, or the salar itself. In brown border, reddish border, we see the mining property of lithium-1. And in this map, I want to show the geology in general. To the east, in red and magenta, we have the Precambrian basement, metamorphic and intrusive, Precambrian and Paleozoic, in fact, known as rocks belonging to the Pampean Sierras. And in green, we have the basement, or rather the marine Ordovicic rocks. And in brown and gray, we have tertiary sedimentary rocks and volcanic rocks. This is the schematic profile or section. This is an east-west section of the eastern side of the salar, where we have the tertiary rocks in yellow at the left to the west, and basement rocks in the east side, and the basin filled in with material from the salar. I will talk about the sample taking and geochemical analysis. 133 trenches have been dug in the mean lithium values for the subsurface samples. Then 1.66 milligrams. Then all the values, a medium, maximum, and minimum: 8,902, 14,799, 2,963. As you see, we have low amounts compared to what our colleague presented before. This is a picture that shows the trenches excavated with excavators in the salar, with the surface covered by the saline crust, and the subsurface water present with a yellowish color. There's a high content of salts. This trench was excavated at the moment of taking the picture, and this was excavated 2-3 months ago, and there's a high saline content here. In this picture, we show the trenching on the left with a machine trenching to extract the brine samples. In the right picture, we see the mechanized trenching machine with an auger system that allows to extract samples at 4 meters deep. This is the sample distribution of the subsurface sampling. In red, we have the border of the lithium-1 property in the salar. We have the lithium distribution in milligrams per liter. In magenta, we have the highest values detected in the surface, in the subsurface sampling, and in blue, we have the lowest values. We see that there's high concentration in the northeast, in the north and south part. In this case, we have the same content of lithium in the near surface sampling, but in this case related to a line of estimation of the salar sediments in the basin with values of 50, 150 meters and more than 200 meters of estimated thickness with 2D gravimetric sections, and those thicknesses are being proven with diamond drilling. This is a potassium distribution in milligrams per liter. They have a good fit with the lithium values. And this is the magnesium distribution. The magnesium-lithium ratio varies between these two ranges, and these values give what we mentioned before of 1.66. Geophysics. At this moment, geophysics carried out in the salar has consisted on point taking through gravimetry. This has been made with Quantec company, and based on these data, 2D sections have been created, and they allow us to infer which is the geometry or the distribution of the roof of the basement, the crystalline basement we have in the salar, and the estimated depth of the sediments, and determined by density. We have in the middle the satellite image of the distribution of the sections, and in the upper part we have the north section. To the left we have tertiary sediments. The peak we see there is tertiary sediments and quaternary sediments. And in the section below, we have the south section, where we see the development of two sub-basins in the east sector of Salar de Hombre Muerto. Another task that has been done already are the drill holes with rotary equipment. It's a 6-inch diameter rotary piece of equipment, and it has allowed us to know the lithology of the salar at least up to 60 meters. In the south sector, in the upper part, we have 30 meters of medium and fine-sized and consolidated sand, and from 30 meters below there's a saline body that contains brines, of course, and the sampling of these brines coming from the wells and drilled with rotary systems allowed us to verify the presence of brines with lithium values of 620 to 840 milligrams. This is the piece of equipment we were talking about, which was used for drilling. The work in this type of salar is quite hard. It is necessary to do previous work before going in. These are soft soils, and it is necessary to create platforms for the equipment. What are we doing today? Well, today we are working in diamond drilling with light equipment, and we also are starting the stage of evaporation trials. In the case of the diamond drilling, we have more than 300 meters drilled already with core sampling And from the course, we analyze porosity of the sediments. And during the drilling, we use our own methodology to collect brine samples at different depths and trying to prevent the contamination with the drilling sludge that could be the worst problem we could have. At this moment, I cannot comment on the geochemical results. There are some ready, but they have not been published yet, and I can't give any advance on that. Well, this is a view of the equipment. The surface of the salar is in the central part. The other work that has been carried out is the evaporation test. We already have the equipment in the field. The layout of the evaporation ponds is being planned to be finished in late September, and this type of test is designed at this very moment thanks to the previous study made by the lab, where there were lab skill tests made in order to establish the characteristics of the brine and to be able to design a larger scale test. This is essentially what we will be doing. We have holes in the salar, three-cone rotary holes. The brine is sampled. It will go through a treatment to extract magnesium. In those ponds, we will have an in situ evaporation process. Then we eliminate magnesium and sodium chloride. Then the potassium chloride will be precipitated as sylvinate, and we will be producing lithium carbonate from the salar in a couple of months more. We will have this information available then. So this is a summary of the activities from 2010-2011. In late 2011, we will finish the feasibility study, and in 2010, we end the pre-feasibility stage, and during the first quarter of 2011, we enter into the feasibility study. And here we see the different tasks carried out today. And we shall continue working with each stage in particular. Well, that's all. Thank you.